Two of the body's most consequential hormones, insulin and cortisol, operate in a continuous, opposing relationship. Understanding how they interact is central to understanding muscle repair, recovery, and long-term structural resilience. Diet and stress play a role in either supporting or disrupting these natural balances. Cortisol is the body's primary glucocorticoid, released by the adrenal cortex in response to physiological or psychological stress. It mobilizes energy by breaking down glycogen, fat, and, critically, skeletal muscle protein. It is catabolic by nature. Cortisol is a part of our body's natural hormonal makeup and plays an important role. Healthy cortisol levels are key. Insulin is a pancreatic peptide hormone. Released in response to rising blood glucose, it facilitates cellular uptake of glucose and promotes tissue repair. In the context of muscle physiology, it acts as an anti-catabolic signal, not by directly building muscle mass, but by opposing the breakdown process. Similarly, healthy insulin levels are key. Observations confirm that cortisol directly antagonizes insulin signaling, inhibiting GLUT4 translocation, suppressing glycogen synthesis, and reducing glucose uptake in skeletal muscle. In practical terms, prolonged elevated cortisol reduces the muscle's ability to respond to insulin effectively. This antagonism matters for muscle longevity. The body, when under manageable acute stress, uses this mechanism purposefully, mobilizing amino acids to fuel the immune response and hepatic gluconeogenesis. The problem arises when the stress response is prolonged or when the nutritional environment fails to support a counter-response. A moderate, controlled insulin response, the kind generated by a balanced meal containing complex carbohydrates, provides the counter-signal. It communicates to the hypothalamic pituitary adrenal axis that the body is fed and physiologically safe. This moderates HPA axis output and, over time, attenuates cortisol elevation in a natural manner and allows for its natural and important function to be maintained. Cortisol is not bad and is a necessary hormone. It's the frequent and prolonged impact that matters. Kramer and others, 2006, demonstrated that carbohydrate ingestion around resistance exercise produced measurable post-exercise decreases in cortisol, alongside increases in circulating insulin, and a concurrent reduction in muscle protein degradation markers. This is not a spike and crash strategy. It is the sustained, stable insulin signal that matters, achieved through foods that digest gradually and avoid sharp glycemic excursion. Legumes, whole grains, root vegetables produce a slower, more sustained insulin response. This sustained signal is sufficient to attenuate the catabolic cortisol environment without driving the reactive hypoglycaemia, which is low blood sugar level that can itself become a stressor to the HPA axis. Eating strategically, specifically timing carbohydrate intake to support recovery windows, can modulate the cortisol-insulin axis in a direction that preserves muscle tissue over the long term. Cortisol and insulin are not adversaries in isolation. They are parts of a finely regulated system. Supporting that system through informed nutritional choices is one of the most physiologically grounded approaches to muscle longevity. Based on individual suitability and health status. This is part 22 of the Carbohydrate Metabolism series on Go Deeper Health. Subscribe for more weekly segments on holistic high-performance health.